All right, today we're going to break down one of the most powerful tactical missiles out there, the Army Tactical Missile System, better known as ATACMS.
And let's get right to it. The thing that makes this missile so incredible is its speed. We're talking 3 times the speed of sound, Mach 3.
So, you gotta wonder, right? How in the world does it get going that fast? And maybe even more impressively, how does it hit a tiny target from over 100 miles away? Well, that's exactly what we're gonna get into. To really get how it all works, we've got to look under the hood at the engineering of this thing.
All right, first things first, let's meet the ATACMS and figure out why everyone calls it a total game changer on the battlefield.
So that Mach 3 number, it's not just some abstract figure. That translates to a mind-blowing 2,300 miles per hour. I mean, just try to imagine that. At that speed, trying to shoot it down is, well, it's next to impossible.
And to really put that into perspective, take a look at this. You've got other big-name cruise missiles, right? Like the Storm Shadow or the Ka-101. They're fast, but they top out around 600 miles an hour. The ATACMS is nearly 4 times faster. It's not even playing the same sport.
So what does this thing actually look like? Well, picture a solid fuel rocket that's about 13 feet long and 2 feet across. It's heavy, too, weighing up to almost 3,700 pounds. And the business end? It's carrying a warhead that can be up to 500 pounds. That is a serious punch.
Okay, so now let's take this thing apart, piece by piece, and see how all the different components work together to make the magic happen.
Think of it like this. Up front, you've got the trigger, the impact sensor. Then you have the brains, which is the guidance system. The fist, of course, is the warhead. The engine is this massive rocket motor. And finally, you have the feathers, the control fins that steer it.
So, that brains part is really a 2-part system. The first part is something we all know, GPS, the Global Positioning System. It listens for signals from satellites to figure out exactly where it is. Super accurate, right? But it's got one big vulnerability. It needs to be able to hear those satellites.
And that's where its backup brain comes in, the Inertial Navigation System, or INS. Now this thing is totally different. It's completely self-contained. It doesn't listen for anything. Instead, it just feels its own movement, every single change in speed and direction, from the second it leaves the launcher.
So why have both? Well, that's the genius of it. If an enemy tries to blind the missile by jamming its GPS signal, the INS just takes over instantly. The missile doesn't even blink. It just keeps flying straight to its target. That redundancy is what makes it so incredibly reliable.
And this missile isn't a one-trick pony. It's all about having the right tool for the job. And that comes down to its interchangeable warheads. Got a hardened target, like a concrete bunker? You use the unitary warhead, a single 500-pound high-explosive bomb. But what if you need to hit targets spread out over a large area? Well, then you swap in the cluster munition, which blankets the area with hundreds of little bomblets.
So that brings us back to the big question. How does it get that insane Mach 3 speed? The secret sauce is its solid rocket motor.
It's actually a pretty elegant and brutally simple process. First, an electric signal lights the fuse, so to speak, igniting this solid block of propellant. Now, this isn't like gasoline. It's a pre-mixed brick of fuel and oxidizer that burns like crazy, creating a ton of pressure inside the motor casing. All that super hot, high-pressure gas has only one way to go, out the back through a nozzle. And thanks to Newton's third law, for every action there's an equal and opposite reaction, that blast of gas shoves the missile forward with incredible force.
But, a missile's no good without a launcher. So let's talk about how these things are actually deployed and used on the battlefield.
Basically, you've got 2 main options for firing an ATACMS. There's the M142 HIMARS, which is the nimble-wheeled truck version. It's lighter and carries 1 missile. Then you have its big brother, the M270 MLRS. This one's a heavier, tracked vehicle, and it can carry 2 ATACMS at the same time.
Now, staying alive on a modern battlefield is all about not staying still. These launchers use a tactic that's famously called shoot and scoot. It's exactly what it sounds like. They roll into position, they fire the missile, and then they get out of there fast. And this isn't just about hiding. Enemy radar can actually track a missile's path right back to where it came from in just a matter of seconds. So for these crews, speed is literally survival.
The ATACMS has had an amazing run, dominating for decades. But as you know, technology never, ever sleeps. So let's meet the next generation, the Precision Strike Missile, or PRSM.
People call it PRISM, and it is a huge leap forward. You've got a better motor, a deadlier warhead, but here's the real kicker. It's smaller.
So that HIMARS truck that could only carry one ATACMS, now it can carry two PRSMs. Think about that. You've just doubled the firepower of every single launcher out there. That's not just an upgrade, that's a complete strategic game changer.
And the whole design philosophy here is really smart. As Lockheed Martin points out, they basically built it with extra room inside on purpose. That space is for, well, for the future. It means they can easily add in new software, better tracking systems, whatever comes next, without having to redesign the whole missile.
And that really brings us to the big takeaway here. This whole evolution, from the ATACMS to the PSRM, it's part of a much bigger story. Missiles are getting faster, they're getting smarter, and they're getting incredibly precise. And that leaves us with a huge question to think about. As this technology keeps accelerating, how is it going to fundamentally change what battlefields even look like in the future?